Hello and welcome back to compiler programming. This is a state where we left off, and basically what this is doing is just inside of this buffer it's setting the first 10 bytes from 0 to 9. And what I want to do today is I want to make a separate function that will be called like print S32 or something like this, or we can actually call it print because we have technically overloading, so we can do S32, we can do whatever we want. So here I would say integer is S32, it doesn't return anything, it will have a buffer, we will need that 0 code, we keep all of this stuff, but here we actually need to change the logic. So we would say that so there is a pretty standard way how to print integers. Basically you are constantly dividing them by 10 and taking a remainder of the division and add the ASCII code of the 0 to that remainder, and you're good. However, if you just do that, you will end up with number in reverse, and that's not good. So you either need to reverse the bytes that you wrote for the number, or you can do it in two passes where you first count the number of digits that you have, and then you use that to put the number in the right position in the buffer. So I will use the second option, and this is what we will do first. So I will say that we have a counter, and counter is integer. And then we say while counter is not 0, so that's first thing that we'll need to implement. We don't have not equals, and I don't think we could do well, actually we could probably get away with this. Let's see what's gonna happen when I try to use it. And while counter, we just say that, or we can call it temp, or we can call it, I don't know, yeah, whatever, temp. And then we would say count is 0. And here I say count is count plus 1, and temp is temp divided by 10. So I also don't think we have division right now, so that's something we'll need to do. And as the first thing what I will do is I will say that buffer is, or I will call this set array item, buffer 0 and 0 code plus count. This is technically unsafe in the sense that it will print wrong thing if you have more than 9 digits in the number, but I just want to get something out, and this way we could actually print what we have. So this sounds fine for now. We can comment all of this stuff out and all of this, and actually we can basically comment out everything. And inside this bus we are just saying print of let's say 42. So let's try to run that, but I expect it will complain that it cannot find entry, cannot reduce, something like this. Yeah. So it has no idea what to do with the slash, which is perfectly fine. We can easily tell it what to do with it. We already have plus, right? And we have less than, and we have more than. So this will be just one more of these functions, which we might want to figure out how to simplify further, but let's see. Okay, token rewrite divide. So this is gonna be a slash, and we will just say divide left hand side by the right hand side, and this is operator. That way we need to change it. So this sounds good, and we have this token expression. This needs to be before plus because it has higher precedence than plus. It's not that it's important right now, but it will become important when we have bigger expressions. Okay, let's see if that builds. That does build, and we can check what's going on further. Okay, so we are failing with same value type. This is something that is easier to check with the debugger to see the trace of what's going on. Okay, so we are inside of token rewrite divide, and the issue here is something that we actually dealt with in other functions already, and that's basically we need to coerce one of the sides of the operator to be the same size as the other one for integers. So this is gonna happen here, and if I search for plus or minus, there is this assert same value type or can implicitly move cast, and this is what we need to do. Where is divide? Yep. So this is good. Okay, this is the immediate case. We have temp. Here using S64. I'm not sure that's how it's supposed to be. No, this is for the xtemp. Yeah, that's fine. We are moving into RDX temp RDX. Then we have a descriptor. Yeah, so this is something that needs to slightly change. Basically, we have this larger descriptor, and this is what we will need to use here for this stuff, so for actual things that we're using. So register A, move value, register A. Okay, so that should be fine. And same here for divisor. We do larger descriptor. We do larger descriptor here. Actually, no. Here is fine. And then we check this stuff. And then we divide. Okay, so we divide racks by the by the divisor. Okay, that sounds good. And we create the temp value, restore RDX, and we are done. So let's see if that makes sense now. Well, it looks like we are having a bit of a problem with the division, and we never terminate. So where is this program? Quite a few tests, which is good. It's bad that I cannot find the right one so far. Macro. Should be somewhere over here. Yeah, I should be able to run these bus. I just noticed that we have wrong name for this test, so we should fix that. Anyhow, let's try to see what's going on inside of assembly and why we are infinite looping. Or are we infinite looping even before that? Okay, that's not very good. Okay, are we getting to here? No, we are not. Okay, so debug, break all. That's not very nice to say that. Okay, so it complains that the source is different. Let's try to fix that. Maybe that's the issue. Okay, yeah, now it was able to do the right thing. So we can go inside of this stuff and try to see what's going on. So this is not very interesting. Now we go to the actual function that is doing the counting. So moving. So this compares okay, what does it do actually? Let me check. While temp. Okay, so it takes ECX and it compares it with the 0. That should be fine. It is not equal to 0, so if we put ECX into here, we would see that it's 42, which is what we expect it to be. So it's not equal. We move Rex for some reason to there. I guess we are saving Rex. So we are loading 42 into Rex. We are loading 10 into AL. So that's not very... It doesn't work very well. So the issue here is that we're just using RAX as our temporary register everywhere, and that causes issue because we also use it as a temporary register inside move value, and move value was now overwriting this stuff that we were putting into here. For now, the easiest fix is to do it as the last step, and first put this divisor into there. So that should be fine now, I guess. Let's see. So let's rebuild this, and I will still go through the assembly and see what's going on. So F11, 10, 10, 10, 11, 10, 10, 10. So yeah, now we're putting 10 into AL, we are extending it, we are moving it. So this is very strange. Okay, no, everything is fine, I guess. Wait, just let me take a look again at what is going on here. So we get A divided by B. We put B onto the stack. Then how it was before? Oh, it's supposed to be like that. So I was wrong again, because this extension is part of the part of setting up this register, not anything else. So maybe it is worth putting it into here as a single block, so it's more obvious that this is part of the same thing. Okay, let's try that again. Like this, go there. Okay, now it's better. We put 10, we extend, we save. This is a bunch of very useless operations, but I'm not interested in the speed at the moment. I'm more interested in correctness. So we would put this stuff. So we put 42 into EX, we extend it, we divide EX by 10. Okay, that seems perfectly fine. And then we would do a bunch of moves. So let's just try to skip till jump. So we are jumping, and right now I would expect that this RSP plus 64H, if we cast it to an int, actually it's supposed to be int star and then star, something like that. That does not look at all like what I want. Because I'm looking at the wrong thing. It shouldn't be 48, it should be 64. Okay, great. So actually this seems now fine. We divided 42 by 10. It's an integer division, so we throw away the remainder. We end up with 4. And if we go through another loop of this, we should end up with 0. Now it will be equal. We jump to here, we do a bunch of setup, and then we call a write file, and we should see 2 in here, number 2, if everything is fine. Actually, no. Now, this was just the setup to get the STD handle. So now we should see 2, and we do see 2. So that's great. Cool. So we now can count the number of digits in the number, and that is very nice. Okay, what's left now is to actually do the changes of each of the digits into ASCII code and putting it out. So now I say while count, count is count -1. Oh, I still haven't fixed that, so this gonna be unfortunately count plus -1. This is not cool, but I can live with it for now. And the reason is right now distinguishing unary minus versus binary minus is kind of complicated, and I don't want to just deal with it right about now. Okay, so this loop will now count backwards, and we need to start actually putting the remainder of the division into right places. Now that I'm thinking about it, maybe it would be better if I actually did it in the right order, or maybe not. It doesn't matter. So now I can say integer is integer divided by 10, and I will have a problem with the sizes of numbers here, because when we do this division by 10, we will end up with how should I explain? Basically, we want to get the remainder. So we say digit is integer percent 10. Oh, first of all, percent is something that we don't have neither in macro code nor in parsing, so that's something to add. But then digit is actually going to be a 32-bit integer, and we don't really have a way to convert it to something smaller. And this is another thing that should actually should be done. So I'm not sure how I want to deal with casting. I guess I can have another built-in function, sort of, that just or maybe I can do it like that, where just any type is a function by itself to cast. I'm not sure. Maybe cast is a better thing because it's more searchable. So something like that would be what we want. So, and then we would say zero code plus digit. Then we need another temporary, which is an index, and we would say index. Well, we can actually say index less than count, and then we increase index, and then we can use index here. That seems fine. So actually, if I don't do this and instead I'm just gonna hard code 0 into here, we should see two zeros in our code written out. Let's see if that is true. And well, here is a semicolon. I already know that, but their message is kind of not nice. So index is missing. That's because it's not called index here. It's fine. Okay. We are again infinite looping, I guess. Let me check if that makes sense. So index starts at 0. The if here is index less than count. Okay. And then index is index plus 1. We should not be really infinite looping. So I guess we need to look at the assembly, which is going to be quite gnarly now, because this is a pretty long function at the moment. I guess I could split it in two just so it's easier to look at it, but first let's see if I get stuck. So we have this loop. This is 1, this is 2, now it's 0, we jump here, and this is the start of the second loop, where we are dealing with, so basically right now we are here, and this move is exactly this index equals 0. So maybe I should actually move this here and make this slightly smaller, and so it's kind of, we can look both at the source code and the assembly. Okay, so this is a byte, we load it, we move it again, we compare AL with this byte. So char star RSP plus what? 5F and 60. Yeah. So 60 is 0. And then 5F is 2. Well, that is what I would expect to happen. So we are saying that 0 is less than 2. We should get true. And then we get 5e should be 1. Yeah, okay, that makes sense. If we compare, and if it equals, we jump. If not, we continue here. So this just moves the array, that's fine. And then we moving 0 into the right position array. So this so far seems okay. And now we are doing the division, which we don't really care about because we can even comment this part out, to be honest. We are adding we are taking 1, we are Then we move index, okay, into there. We add 1 to the index. Then we do a bunch of unnecessary moves. The whole point is that index is now 1. So that makes sense to me. We go through this thing and we have an issue, I guess. So this is supposed to be index. And we are somehow clearing it. Or maybe this is supposed to be index. Actually, I guess this is supposed to be index. So we go not a loop here. No, something is actually screwed up with the index. So I think that 60 is index. Let me verify that. Wait. Oh. Okay, now I get what's going on. This is a really, really nasty problem, I guess. Let me think about that. So, right now, force value, where you are. Okay, so this is the main function, and we have a parse block in here, and parse block is not doing one thing it should be doing, and that is it does not push an extra scope, as we say here. So let's do that. We should say scope star block. Scope is scope. Is it like make of scope? We can put it after the assertion, and then whenever we are putting the scope here, we are supposed to actually pass on block scope. Because otherwise, what was happening, let me explain. I will need this code to explain. So there were two problems. Problem number one was that we were not detecting it, but it's something else. But the original problem is that we were expanding this macro, and we would end up with a label for loop, but this would not create a new scope, which means that if we have two loops, we end up overwrite, like we will not create the right label, and we would end up jumping to the top of the loop. And this is what I saw in the assembly output of this assembly. So now that we are pushing the scope here correctly, we should be fine, I hope. Let's see if that is true. So let's build this, and let's try this out. Okay, so we are not exploding, and more so, we actually end up with nice 2 zeros here. So that's good. Okay, and yeah, let's continue. To continue, we now need to start doing something about this part, where we are doing the cast and then the integer. Well, first of all, let me duplicate this and start with just doing this, which is the first thing that will not work. So we have here divide, right? Now we would have the same thing with remainder, percent here. Sounds good. And we also actually need to implement it because right now there is no such thing as divide. So there is this stuff, let's say remainder, and we would have remainder, and let's jump to divide, which we already have here, and it will be same basically as plus or minus, because it is the same operation. The difference is where does what we use as the result, because if we look into how this works, let me open up Firefox and go to this stuff, and then we go to idiv. So you can see here, for example, this is 432-bit. The result is stored EX and remainder is stored in EDX. So technically we get both when we divide, and that means that here I would just need to pass an extra thing. I just want to see how we do it in plus or minus, so we pass it as a first thing. Okay, so this is not very nice, but I would say divide operation, and then divide operation divide, and divide operation remainder. This might not be how we do it long term, but for now this is fine, and I accidentally closed the file. So let's get back to it, and I didn't even save it, which sucks a bit, but it's fine. Type def divide and remainder. Okay, and we pass in divide operation, and let's see what we need to change. So I think the only thing that we need to change is here, where we say value star result, right? And I would say if operation is divide operation divide, then we do this. Otherwise, we are moving from reg, and actually we will need another value here because we are not, we need it with the right size. So we will be moving something like this, register D and larger descriptor. Something like that. So now I need to fix the divide stuff, which is here, and I guess I need to keep this functions, so it is easier to use them. Let's copy this stuff here and say return. So first of all, I made a typo with remainder. Return, divide or remainder. Divide operation divide. And builder A, B. And then the same thing will go for remainder, right? And then we say remainder. Let me check here. Makes sense. Let's see if that builds. Temp undeclared identifier. That should be result. Okay, at least that builds. Let's see. We should not see any change in output, but we also should actually compile, and this is pretty easy to fix. So at some point in the future, we'll also need to fix the precedence, because right now, like, Vision actually has higher precedence than remainder. Well, in reality, they should have the same one, which is not something I have at the moment, but that is also okay for now. Okay, so we are not crashing, we are doing something resembling division, so that is very, very good. Means we are ready for the last part, where we are doing the casting. I mean, honestly, let's see what's gonna happen if I do this. I hope I will get an error, but you never know. Yeah, so we do get the error, and that is good. So now I want to say, I will split it into operations maybe, so it's easier on the parser, and do it like that. Digits S32. Okay, so we need to figure out how to do cast, and I will take cue from this how set array item works and go from there. So here's our code, which we actually need to uncomment. Let me do that before I move forward. So let's do it like that. So let's prepare for the cast, but then I want to actually get rid of all of this. So this stuff should go. For now, I'll just comment this out and say return false. So let's see if that builds, and let's see if we can uncomment that code that was left from the previous video. And the idea was that I wanted to check SIB, but there is also a version of this when we don't need dynamic index, where we know it right away, and that version is just simpler. So let's see if that still builds, and at least it doesn't explode. Okay, doesn't look to be. So let's continue with the cast. So what is the cast? Well, it's pretty easy. It is cast and then paren. But instead of the generic call arguments, we would actually need to do something better, or maybe not. Maybe this is actually fine. So I expect 2 arguments. Then this is going to be type as the zeros one, and then the value as this one. then I expect that the type descriptor type is descriptor type, I think, or something like that. And then I would say descriptor star target descriptor or cast to descriptor. And then what? Well, we just say type descriptor type descriptor. I already forgot how is it there. So I can do like force type, I think, right? So we have scope lookup type. How does scope lookup type work? It's so descriptor type, and then descriptor is type descriptor. So this is what we want. This is going to be cast to descriptor. We don't care about this stuff. And then what do we want to do? Well, we want to assert that their general type is the same at least. So we say value descriptor type is the same as cast to descriptor type. So they're, for example, the same as integers. And we, for now, even actually can assert that we can only know how to deal with integers. So descriptor type integer, right? And then it becomes interesting. So I'm actually not certain how to correctly cast number to a smaller one. So maybe we should go and look at compiler explorer output. And I would say that I will return here a char, and I will just say return size. What are you going to do? Oh. Okay, not char star, just char. Come on. I believe that you can do this. Move 0 extend. Is this move 0 extend? Index move zx. Move 0 extend. Copies contents and 0 extends the value. The size of the converted value depends on the operand size attribute. I don't think it does the right thing, to be honest. Is it the right thing? So it puts ECX in the stack and then returns, return, yeah. That's very strange. Is this what all compilers do? Because we are trying to put a bigger sign type into the smaller sign type, and it looks like it throws away the number. Where is the stuff here? Again, move is your extent. Move by to word. Move forward. So this is extending, but we want We want to cut it down, no? So let's put this stuff here and see what is happening. So this is MSVC. I guess I want to look at cling. You don't like the flags? Minus 03. Move ex EDI. So I guess EDI is a return value. This is so strange. I guess that this, so the registers I guess are also little endian, and that would mean that, yeah, if you have this there, okay, so that makes sense. If we are doing it to be smaller, then we don't really need to do anything. Okay, good. That it makes it easy for us. So we need to do just the following. I guess we can really just create a new value that has the same, it just changes up the size of the operand, and that's it. Okay, that sounds good. How do we do that? Well, we say that value star result is temp allocate value. Star value is value with descriptor cast to descriptor, and then operand. So for now, I'll just say fix me, allow larger size, and for now I will do assert descriptor byte size of cast to descriptor is less, or actually let's put it in variables. So we say u32 cast 2 byte size is this. Then we have original byte size is here, and it would be value descriptor, right? Actually, let's do the full thing. It's fine. If cast2 byte size is the same as original byte size, then there is really nothing to do. So we can say that value star result is value. Else, if the byte size is more than original byte size, then it's pretty easy. So I can actually say if cast byte size is not same as original byte size, then we will need to create a new value for result. Something like that. But the actual value will depend on which direction we are going. So if it is less than original, then as I said, we will need to do that, where we are copying or copying partly the original operand, and then we would say operand byte size is cast2 byte size. I guess that should be sufficient, but I want to quickly check what do we have in descriptor integer. Do we also have byte size there? We do, but that is part of the cast2, so that's fine. What about operands? Yeah, so we have register, blah, blah, blah. We have byte size. Yeah, so that should be fine. And in this case, we say that value is temp allocate builder and cast to descriptor, and we just move because move handles already extending from smaller to bigger size. So we move builder value and then sorry, not value, result. This could have been a bunch of unnecessary debugging. Result value, good that I got this. Then we replace it, but we would say token. How's this done? I already forgot. When we want to replace something with a new token value make. Okay. Token value make of, I guess, value token and result. That's quite a bit of typing. Let's see what if it is correct. Okay. Temp allocate. Yeah, it's not temp allocate. It is what do I want to do? I wanted to have stack allocate or stack reserve or something. Okay. Entry, yeah, it's undefined. This is supposed to be just value. It's not stack reserve. It is what? It is reserve stack. Okay, this thing builds, but does it blend? Well, we still should have two zeros because I'm actually not using that value, and I don't even have the cast, so obviously this works. Let's try to have a cast. Okay, we are crashing very spectacularly. So let's see what is going on. And this crash is inside of cast to descriptor because I'm not pointing to the right thing. This is not value, this is type. Let's try it again. And again, we are not crashing, which is very encouraging. Let's try to do this and see if the types match and if everything is okay. So we are fine. So I think I will actually this now other way around, and I should be doing this. So while count, so I will need to do this plus -1, or yeah, it's fine. Plus -1, and then count. Actually, I want to do it as the first thing because here we already need to be indexing and index this one less. So this seems like something like that. Let's see. And we have we? We have? No? Yes? Oh yeah, we have a bit of an issue that we need to copy count. So we say index is count, and I will use index here. Great, amazing. We have 42. We are able to print stuff, and we might actually be ready to make this happen. So let's try that. So while we say I is 0, while I is less than 100, we do what? Well, we say I don't have else if, so I will have to do something complicated for actual FizzBuzz. I will have to say like something like custom is 0, and I would say if I percent, so if it's divisible by 3, I need to print fizz, right? So this is getting like proper programming, so quite big programs. That is good. Std out handle is this stuff, and I would say std out handle. We would put something like fees and then 4. And we also need to say custom is 1. Then if it is %5, then we write buzz, and if I don't have not, so I have to reverse this and say print digits or print number, and it would start with 1, and here it will be turned into 0, and I would say if print number, then print of what? Print of I. Okay, that is a lot of code, and if it works, it will be a miracle. Let's see. Okay, it does not work, and I think I need to put semicolons here because unfortunately if right now requires them. Unsupported byte size when dividing. I assume this comes from these guys. So let's, if I uncomment that, do I even get numbers from 1 to 100? I do not. That is a bit unfortunate. Does it work like that? So something is not exactly right. I wonder if it is because I start I with 0. Yes, something is not. Ah, okay. I think I know what's going on. Um, count actually needs to start with 1, and then here I was forgetting to do I is I plus 1. Let's try again. So this is not very encouraging. Okay. This is actually not correct. So yeah, 0 is a bit unfortunate, so I will do it like this. And let's see if that works. If that doesn't, I will probably not debug this and we finish it some other time. Okay, there is something wrong. We didn't quite get to FizzBuzz, but we can now print numbers, which is pretty good place to finish for now, and hopefully next time we can finish up our adversary and make it work. Thank you very much for watching if you made it this far, and hopefully see you next time.